Partial fraction decomposition. Woo, that is a mouthful. We're going to focus this video lecture on one particular case, and that case is non-repeated linear factors. And I'm going to guess that a lot of what's up here, a lot of the vocabulary up here doesn't make a lot of sense right now. And so we'll pull that together in just a few minutes. So our objective, and again, it's going to have some vocabulary in it that we're going to have to pull together. Okay, our objective, decompose a rational expression into partial fractions when the denominator has only non-repeated linear factors. Again, oh my goodness, what does all that mean? Well, let's put this in. Let's work to have this make some sense to us. Okay, so what we're going to do here is we're going to do something we know. We're going to add two rational expressions. So here's what I've done. The first rational expression is 2 over x minus 2. And the second rational expression is 3 over x plus 1. So I have this rational expression plus this rational expression. And we know when we add fractions, we need a common denominator. So in this case, the common denominator is x minus 2 times x plus 1. We've done this. And so this goes into this many times. So the numerator is going to have a 2 times x plus 1. And this fraction goes into this many times. So we're going to then add 3 times x minus 2. Okay, so now we have a common denominator, and we're going to put it together. There's our added numerator. I'm going to distribute. So 2x plus 2 is right here. 3x minus 6 is right here. And I went ahead and multiplied this out. I distributed this as well. X squared minus 2x plus x is minus an x, and then minus 2. And now I'm here. The numerator can be simplified. 2x's and 3x's is 5x's. Positive 6 and positive 2 and negative 6 is negative 4. Numerator is 5x minus 4 over x squared minus x minus 2. So here's what we know. The rational expression 2 over x minus 2 plus the rational expression 3 over x plus 1 equals the more complicated rational expression, the sum, 5x minus 4 over x squared minus x minus 2. Okay, so decomposition, let me come up here to our heading. Decomposition means we're going to decomposing is taking a rational expression. So this is our rational expression. And I want to go backwards. What does it look like as a sum of fractions? Okay, and these two are called partial fractions. Okay, and partial fractions are the parts that make up the single fraction. That make up, oops, I'm getting a little sloppy here, sorry about that. That make up the single fraction. Okay, so let me put this together again for us. We know how to take two rational expressions and add them together to get a single rational expression with a common denominator. Decomposition is going in the opposite direction, taking probably the more complicated rational expression and separating it into an addition problem of two simpler fractions, and these are called partial fraction because these two fractions are parts of this. So that is, there you go. Okay, that's decomposition. Okay, so why do we do this? Let's talk about that. Why decompose? Okay, I'll come up here so you can see that a bit better. Why decompose what I'll call a complicated, rational expression? Why in the world would we want to take this and rewrite it as a sum of two more simpler fractions? Well, as I just spoke to, because the partial fractions are each simpler. Because the partial fractions are each simpler. That's why. This is more complicated to work with. These two are more simple to work with. And if you get into calculus, you'll see where this comes in handy. Okay? So we're doing this because it's easier to work with two simpler fractions, rational fractions, than it is to work with a more complicated rational fraction. Okay, so what is the process? How do we go from here to here? How do we decompose this into its partial fractions? I'm going to turn the paper over because I'm going to put the instructions together with an example. So I recommend you do the same. So, again, how do we decompose a rational expression? And in this case, and there are actually 4 cases, we're just looking at one case here. In this case, the denominator has only non-repeated linear factors. And we'll take a look at that as well, what that looks like. Okay, there are 6 steps for doing this. Step 1, if necessary, factor the denominator. Step 2, write one partial fraction for each factor. Step 3, multiply through by the bottom so that we no longer have fractions. Step 4, expand the right side. Step 5, we're going to gather our powers of x together and our constants together. And then step 6, we're going to write as a system of linear equations and solve that system to find the partial fractions, the partial fraction numerators. That's a lot. Okay, so we're going to do a couple of examples and go through it. So here's our example. Okay, we're going to use this example right here. We're going to start with this because we know what the answer is, and we're going to use our steps to go from here to these two, from here to here. Okay, so our example, make sure I see the steps up there. Write the partial fraction decomposition of 5x minus 4 over x squared minus x minus 2. Okay, so step 1, factor the denominator if necessary. This denominator is not factored. Let's factor it. Step 1, 5x minus 4. The denominator is a quadratic. It is a factorable quadratic. It factors as x minus 2 times x plus 1. There you are. There's step 1. Okay. Step 2 says, write one partial fraction for each factor. Now I want you to notice something here. I have 2 factors, and each of these, there's no repetition. So that's the non-repeated part right here. Nothing's repeated. There's one factor of x minus 2 and one factor of x plus 1. And they're both linear. There's no x squared or x cubed down in the denominator. These are both linear factors. Okay, so step 2, we're going to write this. Okay, we're going to write this as a over x minus 2 plus b over x plus 1. So this is step 2 right here. Write one partial fraction for each factor. So I wrote one partial fraction for the factor of x minus 2. I don't know the numerator, that's what we have to find. And I have a second partial fraction for the factor x plus 1. I don't know the numerator, that's what we need to find. So I gave the numerator for the first one the letter a, and the letter b for the numerator of the second one. Now our goal is to find a and b. Okay, now if we go back over here, we know what they are. A is 2 and b is 3 because we've already been this direction and back, so we know that a is 2 and b is 3, but we're going to solve it algebraically with those steps. Okay, step 3. Multiply through by the bottom so that we no longer have fractions. Okay, so here's step 3. I have 5x minus 4. I'm multiplying both sides by x minus 2, x plus 1. And I have a times x plus 1 plus b times x minus 2. So I multiplied through by the common denominator to get rid of the fractions. We've done that as well. Okay, step 4. Let's expand the right side. The right side has some multiplication going on. So let's expand it. The left side, 5x minus 4. The right side, a times x plus a. Distribute the a plus b times x minus 2b. Distribute the b. Okay, step 5. Let's gather our powers of x together and our constants together. Okay, the left side, 5x minus 4 is good. Let's gather our x's together. So I have an ax plus a bx. Okay? These are my x terms. We gathered them together. Okay? And I have a constant. Well, a is a number minus 2b. And that's just a number. So this is gathered my x terms together. This is my constant. Are my constants I've gathered together. Okay? Now, I'm going to rewrite this, and it's going to look a little funky. Okay, so hang with me here. Notice I'm going to rewrite this left side as 5x minus 4. Right side, I'm going to factor the x out and write it as a plus b times x. I factor the x out, and I'm going to leave my constants alone. Okay, so there we have it. This is gathering the powers of x together and the constants together. Now let's take a look at what this means. The coefficient of the x is 5. X coefficient. The coefficient on this side of the x is a plus b. This is the x coefficient. So if this is going to equal this, then this must equal 5. This is my constant, negative 4. I'll write down CONST for constant. And this is my constant on the right, a plus 2b. Okay, so this step 5 is probably the most difficult step for people. You've got to kind of get those x's together, factor the x out, and then you've got to kind of match it up a little bit here. Okay, I'm going to look at step 6, write as a system of linear equations and solve to find the partial fractions numerators. Okay, well let's notice. Okay, I need to have, here's a system, x coefficient equals x coefficient. So a plus b is equal to 5. These are the x coefficients. That's an equation for the x coefficients. For the left side to equal the right side, a plus b must be 5 to have 5x. for the left side to equal the right side, a minus 2b must equal negative 4. And these are the constants. Okay, there you have it. This is a system of linear equations. You can solve this using graphing. You can solve this using substitution. We can solve this using elimination. I'm going to solve it using an augmented matrix because I think that's kind of neat and pretty simple. So I'm going to come up to here. Okay, I'm going to go into my calculator. I'm going to go into my matrix menu under math and go to that RREF, reduced row echelon form, and press enter. Now I need a 2 rows, 3 column matrix. So I'll go to my matrix. It's already done here. I've got 2 rows and 3 columns, so I'll press OK. Now I have a 1, 1, 5 in the first row. In the second row, I have a 1, negative 2, negative 4. I'll close my parenthesis, I'll press enter, and it turns out that A is equal to 2 and B is equal to 3, because I have on the left, I have my 1s on the diagonal and 0s elsewhere. So A is equal to 2, B is equal to 3. So this right here tells me A is equal to 2 and B is equal to 3. So, way back when the question was, write this looking like this. So 5x minus 4, okay, over x squared minus x minus 2 can be decomposed into A, which A is up here, 2 over x minus 2, plus B over x plus 1, and B is 3. 3 over x plus 1. So we've just taken this one, and we've decomposed it. We've written this one in its, as a partial, in its, right, we wrote the partial fraction decomposition of this as this. And if you remember, 2 over and 3 over is what we had back here, 2 over x minus 2 and 3 over x plus 1. So there you have it. Okay, let's do one more example, a slightly bit, just slightly different, maybe a touch more complicated. Okay, and we'll do the steps again. Example 2, write the partial fraction decomposition of x over x squared minus 5x plus 6. Okay, step 1, if necessary, factor the bottom. Okay, well, it can be done. The quadratic in the denominator is factorable. It is x minus 6 times x plus 1. Okay, so there's step 1. Okay, now step 2. Notice I have 2 linear factors and neither of them repeats. So I can use the method we've been talking about. So I'm going to write an A over x minus 6. My goal, I got to come up with what is A. What is the numerator that goes to the denominator of x minus 6 plus B over x plus 1. And this again is step 2. Write this. Write one partial fraction for each non-linear factor. There we have it. Okay? Now, let's remove step 3. Let's multiply through by the common denominator here. And so step 3 is going to give me an x is equal to a times x plus 1 plus b times x minus 6. Okay, so there's that piece. Step 4, let us expand the right side. So step 4, the left side is just an x, the right side is ax plus a plus bx minus 6b. Okay, step 5 is where things get a slight bit more complicated. We want to gather the powers of x together, and we want to gather the constants together. So, I have x, Okay, I have ax plus bx. Remember, these are my, what did I say? These are my x terms. And I have my constant terms of a minus 6b. These are my constants. Okay, now before I'm going to factor the x out, let's rewrite this one. I'm going to rewrite the left side as 1x plus 0. I have a coefficient of 1 in front of the x, and the left side's constant is equal to 0. Now I'm going to factor out the x, so I have a plus b times x on the right side, okay? And I have my constant term as a minus 6b. So here is my x coefficient. Here is my constant on the left. Here is my x coefficient. And here is my constant on the right. And so in order for 1x plus 0 to equal this, it must be 1x plus 0. So now let's set up our system of linear equations. I know that the x coefficient a plus b must equal 1. And I know that a minus 6b must equal 0. Okay, so let's see here. I'm going to do this using substitution. I'm going to rewrite this one as a equals 6b, if I add 6b to both sides. And then I'm going to substitute this into this one. So 6b plus b equals 1. So this is substitution. You can use substitution or elimination or graphing or matrices. This is 7b equals 1, so b is equal to 1/7. Okay, so I know that up here, the numerator for the x plus 1 denominator is a fraction, 1/7. Well, if b is 1/7, I can come back to here. The only way to get a plus b to be 1 is if a is 6/7. Okay, so a must be 6/7 because 6/7 plus 1/7 is equal to 1. So I came up with this using substitution this time. Okay, so I know that when I take this rational expression, x over x squared minus 5x plus 6, and I write its fractional, partial fraction decomposition, well, the x minus 6 denominator has a numerator of a, and a is 6/7, so I'll put a 6/7 over it. And I know that the x plus 1 denominator, b is its numerator, and b is 1/7, so I'll put 1/7 over it. And I'm just going to leave that. I'm not going to get myself overly excited. I'll just leave it looking like that. Now, yes, it's a compound fraction, but we're just going to leave it alone. We found a, we found b, we found the partial fraction decomposition. So there you have it. As I've stated, that is one case that deals with, only deals when you have non-repeated, linear factors. We'll take a look at the other three cases from here.